Right now, as you watch this video, billions of lines of code are running simultaneously across the planet. They keep planes in the air. They route your blood test results to your doctor. They decide which ad you see next. They run the servers that host this very video. Code is the invisible infrastructure of modern civilization. But here's what most people don't know. The story of programming doesn't start with Silicon Valley. It doesn't start with Bill Gates or Steve Jobs. It starts with a loom. And a woman who lived 200 years ago. And a vision so far ahead of its time that the world needed a century to catch up. 1842, London. Ada Lovelace is sitting at her writing desk, translating a paper about Charles Babbage's analytical engine from French into English. But she doesn't stop at translation. She adds her own notes. Notes that are 3 times longer than the original paper. In those notes, she describes something no one has ever described before. A step-by-step sequence of operations that would instruct a machine to calculate a complex mathematical series. It was the world's first computer program. Written in 1842. For a machine that hadn't even been built yet. Ada saw something that Babbage himself had missed. She understood that the analytical engine wasn't just a calculator. It could manipulate symbols. It could process any kind of information, not just numbers. She wrote, the engine might compose elaborate pieces of music, supposing the relations between musical notes were given to it. She was describing the digital age. In 1842. Ada Lovelace died 9 years later, at the age of 36. She never saw a working computer in her lifetime. But her idea never died. 100 years later. World War II. Nazi Germany is encrypting every military communication through a device called the Enigma machine. The codes change every single day. Cracking them by hand is mathematically impossible. At Bletchley Park in England, a mathematician named Alan Turing has an idea. Don't fight the machine with human minds. Fight it with another machine. He designs the bomb, an electromechanical computer that can test millions of Enigma configurations per day. It breaks the codes. It gives the Allies intelligence that historians believe shortened the war by 2 years. 2 years. Millions of lives. But Turing doesn't stop there. In 1936, years before the war, he had already published a paper describing a theoretical device that could run any computation if given the right instructions. He called it a universal computing machine. We call it a computer. Turing never received the recognition he deserved in his lifetime. He was prosecuted, chemically castrated by the British government for being gay, and died at 41. History has a dark habit of punishing its greatest minds. 1945, Philadelphia, Pennsylvania. ENIAC comes online. It fills an entire room. It weighs 30 tons. It contains 18,000 vacuum tubes. And it can perform 5,000 calculations per second. By today's standards, your smartphone is 5 trillion times more powerful. But in 1945, it was a miracle. Programming ENIAC was not like programming today. There was no keyboard. No screen. No code editor. You programmed it by physically rewiring the machine. Plugging cables. Setting switches. The process took days. The people who did this work were called computers. And most of them were women. Jean Jennings. Frances Belas. Betty Holberton. Ruth Lichterman. Marlon Westkoff. Francis Spence. The 6 women who programmed ENIAC are among the most important figures in the history of computing. For decades, history forgot their names. It shouldn't have. They didn't just program the first computer. They invented programming as we know it. The problem with early computers was this: to talk to them, you had to speak their language. Binary. Ones and zeros. Machine code. It was slow. It was error-prone. And it meant that only a handful of people in the world could actually use these machines. Grace Hopper decided to change that. 1952, she writes the first compiler, a program that translates human-readable instructions into machine code. Her colleagues told her it was impossible. Computers, they said, could only do arithmetic. They couldn't process words. She proved them wrong. Her work led directly to COBOL, one of the first high-level programming languages. A language so durable that COBOL code written in the 1960s still runs critical banking and government systems today. Today. 60 years later. Then came Fortran. Lisp. C, Pascal. Each new language made programming more powerful, more accessible, more human. The wall between humans and machines was coming down, one word at a time. For its first 30 years, computing was the exclusive domain of governments, universities, and large corporations. Then everything changed. 1975, a small company called TTS releases the Altair 8800, a computer kit you could buy for $400 and build yourself. A 19-year-old named Bill Gates reads about it in a magazine. He calls the company. Tells them he has a programming language ready to run on their machine. He didn't. He had nothing. He had 2 weeks to write it from scratch. He did it. That was the beginning of Microsoft. 1 year later, Steve Wozniak builds the Apple I in a garage. Steve Jobs figures out how to sell it. The personal computer era had arrived. Suddenly, programming wasn't just for scientists and mathematicians. It was for anyone with curiosity, time, and a machine. The gates had opened. And they would never close again. 1991, a British scientist named Tim Berners-Lee publishes a simple document online. It contains a proposal for something he calls the World Wide Web. He doesn't patent it. He doesn't charge for it. He gives it away for free. That decision changed civilization. Within a decade, millions of people are writing code for the web. HTML, JavaScript, Python, Java, Ruby. New languages for a new world. 1994, Linus Torvalds releases the Linux kernel as open source. Free for anyone to use, modify, and improve. The open source movement takes hold. Strangers collaborating across continents, building software together without ever meeting. Then came Google. Amazon. Facebook. Built by programmers in their 20s, in dorm rooms and garages. Code had become the most valuable skill on earth. And the barrier to entry kept dropping. Every year. Lower and lower. Until a 14-year-old with a laptop and an internet connection could build an app used by millions. And then programming did something it had never done before. It started writing itself. For 70 years, programming meant telling a computer exactly what to do. Every step. Every condition. Every outcome. Specified by a human, in advance. Machine learning changed that. Instead of writing rules, you show the machine examples. Millions of them. And the machine finds the patterns you never could have written yourself. Deep learning. Neural networks. Large language models. Today, AI can write code, debug code, explain code, and generate entire applications from a single sentence. GitHub Copilot. ChatGPT. Claude. The tools that programmers used to build the world are now being built by the programs themselves. Ada Lovelace wrote the first program in 1842. Today, the program writes back. From punched cards to Python. From vacuum tubes to quantum processors. From a single woman writing notes in London, to billions of lines of code running every system on Earth. Programming is not just a skill. It is the language humanity invented to talk to machines. And like every great language, it started with one person who had something to say. Ada Lovelace had something to say. Alan Turing had something to say. Grace Hopper had something to say. The question now is what you will say with it. If this video gave you something to think about, subscribe for more stories from the frontiers of human ingenuity. The next chapter is already being written.